Hey everyone, thanks for watching. This is our continuing AU Passes series. Today we've got model coordination, a comparison of clash management tools. I'm Jason Kunkel with CAD Microsystems, and we're really excited to have Noah Harburger here with us to talk about this exciting topic. Real quick, a little bit about CAD. We are a consulting firm specializing in software, training, professional services, and BIM expertise for commercial and public sector customers in the design, build, and operate industries. We have a team of industry recognized experts, published authors, registered architects, engineers, construction experts, and top-rated speakers at conferences like Autodesk University. Our customers call us when they are frustrated with their design processes and technology and want to improve efficiency, add new capabilities to win more work, and stay competitive. We like to take what we call an educational approach to solving our customers' challenges and are focused on helping each of them achieve their business goals. Following along with that educational approach, here at CAD, education is a core value, and we work hard to empower the design and construction community to share knowledge, to connect with one another by providing platforms such as the AU Passes. This series came from feedback we got from a lot of our customers and their frustration at not being accepted to speak at Autodesk University. This isn't because the presentations and ideas are innovative or they aren't relevant, but simply because you can only pack so much content into a 3-day conference. This is the next in our series of continuing AU Passes, and we are thrilled to have Noah join us. Noah?
All right, well, thank you for the introduction, Jason. Hello to everybody watching this. Before we get started, let me share a little bit about me. In addition to serving as an advisory board member for BIMXT Baltimore, this is also my 20th year working in the AEC industry. For the past 17 years, I've been working at Ayers St. Gross, a multidiscipline design firm. And for the past 8 years there, I've served as the company's firm-wide BIM manager. It's in this capacity that I often help project teams set up their clash detection workflows, adjusting the approach based on project size and complexity. All right, for today's presentation, we're going to be focusing our attention on Autodesk Navisworks and the ACC model coordination. We will also be looking at a few add-ins for Navisworks that help fill in some gaps. These are Newforma Konekt, which used to be called BIMtrack, Sherlock by Flypaper, and the Issues add-in by Autodesk. As we review the software, we're going to try to keep in mind these key items: preliminary software setup, project setup, ease of workflow, establishing coordination areas or zones, hard versus soft clashes, clash grouping capabilities, reporting capabilities, model viewing experience, and access. With that, we're talking about licensing, cost, and so forth. Clash detection is one of the most critical steps teams can take to identify and mitigate potential design conflicts before breaking ground, thus preempting construction issues and rework. Clash detection has been around for a long time, and while you can technically carry out the process manually by reviewing details and design drawings or overlaying PDFs in programs like Bluebeam, clash detection tools like the ones being discussed today have made the process easier and more accurate. When different design disciplines are not communicating, it's easy to find oneself working off of incorrect assumptions. If the architect wants a 12-foot tall ceiling and a space that only has a 12-foot, 10 floor-to-floor height, but they haven't modeled it yet and they haven't given the rest of the team a heads up, the MEP engineers have no reason to believe they can't just route ducts through that space. If design members aren't looking at what the other team members are doing, whether turning off links or failing to ever link in the Revit models in the first place, your project is going to have overlapping elements. A lot of equipment require access and clear space requirements that are not always modeled, so the information may simply be missing. It's also common for the initial layout of a building system to be done without any consideration of other systems. This could end up with all your fire alarm systems being placed just 4 feet off the ground, or all of the ductwork originally being modeled right below your composite deck, where the structural supports, would normally reside. And while we would expect these things to be shifted into the correct place, time constraints can often lead to elements being left in unintended locations. Honestly, all it takes is one person missing a meeting, missing an email, or even just being distracted for a moment in a meeting, for them to miss a change being made by the rest of the design team. We're imperfect creatures, we make mistakes, so it's vital that we put in place processes to help mitigate these mistakes. So let's dig into the software that can help. In 2007, Autodesk purchased a piece of software called Jetstream, made by a UK company called Navisworks. It first came on the market in 2001, just 1 year after Revit, and it became the industry standard because it was the first software that could take files from virtually any design software and bring them together in a single platform to get a comprehensive view of a proposed project's design. It didn't matter what the architects or engineers or fabricators were using to make their drawings. It could all get funneled into the Jetstream. Today, annual subscriptions can be purchased for Navisworks individually or as part of the larger AEC collection subscription that also give you access to software like Revit and AutoCAD. I should point out that Navisworks is more than just a clash detection tool. The software has a ton of tools that contractors and construction managers find vital to their work, such as Timeliner, shown here, a set of construction simulation tools. Now, unlike ACC model coordination, Navisworks is, in its current form, a desktop application. It uses a traditional file system that only allows a single person to work on any given file at a time. While it does have ways for you to share files with other project team members, Navisworks is not really intended to be a collaborative environment where multiple people can simultaneously review and edit a single source of truth. Now, that is not to say that it isn't a solid piece of software. In fact, it has remained an industry standard for so long because it has always done a great job at what it has set out to do. But when it comes to clash detection, there has not exactly been a surge in new features added to the software in the past 20 years. Now, on the one hand, this has created a stable user interface and has made Navisworks a reliable and consistent product year after year, without much in the form of new or sudden learning curves. But there are many features that Navisworks users feel are lacking in the out-of-the-box software. And for many years, it has seemed like Autodesk has just relied on clever individuals and third-party software companies to fill these gaps. The clash detection workflow in Navisworks is pretty straightforward. Assuming you have an established varied coordinate system used by all your various models, you can either export Navisworks formatted NWC files out of Revit, or just append whatever project models you have directly into Navisworks. Doing so creates a federated Navisworks model, also known as an NWF file. The next step can be pretty time-consuming, but mostly just the first time you go through the process. You see, at this point, you are defining the various chunks of data you will want to use in your clash tests. If you do this by searching for specific categories or properties of elements, rather than just manually clicking on the elements you want, you can save these search sets in Navisworks, and they'll be dynamic. That means if new elements of these same categories are added to your model and you go through the process again, Navisworks will automatically include the new elements when you use that same search set. Setting up all of these different search sets can take a very long time, but once you have them set up, you can export them as an external XML file, which you can then import back into any other Navisworks model you make for other projects in the future. So as long as you stick to the same workflow, subsequent projects will end up running much faster. The next step is opening up the clash detective and creating new clash tests. This could be as simple as running all structural elements against all mechanical elements, or it could be more precise, like running a clash test just of sanitary pipes versus all ceilings and light fixtures. Now, just like with search sets, this is something that can take a long time to set up that first time you use the software. But you can once again export the clash tests out of Navisworks and import them again into other projects later on. One thing to note here is that with Navisworks, you can run both hard clash tests and soft clash tests. A hard clash test will find when two elements are actually intersecting with each other. You could set a tolerance of some amount that is acceptable, like a 1/4 inch or 1/2 inch, knowing that there's always a little wiggle room in your building. And it'll then only report clashes where the elements intersect more than that tolerance amount. A soft clash, on the other hand, is looking instead at clearances. Your plumbing lines and supply ducts may all be insulated, but the engineers may not have modeled the insulation in Revit. In Navisworks, you can run a test and designate it as a clearance test, giving the element a 2-inch tolerance to represent the expected insulation. And now it will report any elements that pass through those 2-inch clearance zones as well. All right, so now you have your clash tests. You can run them and get accurate results listing all the clashes that exist in your building. But that's the thing. It will give you all of the clashes in your building. And this is where Navisworks stops being so useful. There are no tools in Navisworks to help you weed out what is and what is not an actual clash you need to be worried about. You may have wanted to find every instance where a vertical pipe was protruding out from a wall, but if you're running a clash test between pipes and walls, Navisworks is going to spit out not only every instance where the pipe is 100% completely contained within the stud cavity of your wall, but also every instance of pipes just passing horizontally through walls as they go from corridor into a room. Additionally, you can't easily sort your clashes by multiple categories. Sure, you can sort them by level, or you could sort them by the nearest grid intersection, but you can't set up a hierarchy where it first sorts by level and then by grid intersection. And simply trying to quickly navigate around a Navisworks model can be challenging in its own right, as zooming in and out can often be hampered by other elements in the model. So without the assistance of some sort of add-in, the process of reviewing all of your clashes in Navisworks, figuring out what are the real issues and what can be ignored, can be an incredibly long and mind-numbing task. And as far as communicating the clashes to your project team, you're either just sharing your screen on a Zoom or Teams meeting while you flip through hundreds or thousands of clashes while struggling to show people where you are in the model at any given time. Or you can package up your Navisworks model and send it out to your team, listing out in an email the clash numbers you want them to take a look at. Navisworks can make a report, but again, it sends out everything. It's just really not good at helping to parse down or organize the data. So that brings us to the add-ins: Newforma Konekt, the Autodesk Issues add-in, and Sherlock. Newforma Konekt kicks us off by using a tool called Group Clashes. Now, this tool originated in 2012 when a civil engineer named Simon Moreau started a blog called BIM 42. Simon developed the tool, and after posting it on his blog, it sort of took off. You see, if you run a pipes versus beam clash test in Navisworks, and you have one beam with like 20 pipes passing through it, Navisworks will catch all of those 20 different clashes and report them back to you individually and interspersed with the hundreds or even thousands of other clashes found all over your building. By grouping the test results by beam or by selection B, it will gather all 20 of those pipe clashes into a single group, and your team can more easily decide whether they should be relocated or if the beam can be redesigned to accommodate the necessary penetration, knowing now the full size and scale of the issue. The group clash tool was acquired by a company called BIM1 in 2015 and placed in a software called BIMtrack. BIMtrack was then purchased by Newforma a little over a year ago and rebranded yet again, but the group clashes tool really hasn't changed much in all that time. It can still save you a ton of time, greatly reducing the number of conflicts you're reviewing, but it isn't the strongest clash grouping tool on the market anymore. That said, you can still purchase the BIM 42 group clash tool through the Autodesk store for a mere $10. And depending on the type of work you do, it may be all you need. But what Newforma Konekt does now, beyond the group clashes tool, is what gives it value. Newforma Konekt lets you publish your clashes to a cloud network, and through a series of other plugins allow you to access the clashes you published in a variety of different software. Now your design team never needs to actually open Navisworks if they don't want to. The electrical engineer can open their Revit model, filter the list of published clashes to only show those that involve electrical, and then navigate to the spot in their Revit model where any of the published clashes exist. This can eliminate the need for lengthy coordination meetings where you're just showing your project team members the issues that need to be resolved, and instead gives the power back to those team members to resolve the issues on their own. And since the data is cloud hosted, you can go to an online project hub and review project metrics, drilling down your data to look at clashes by defined zones, by discipline, by status, and so on. You can also track the progress of your project and see when people are resolving clashes, set up regular automated reports to be distributed daily, weekly, monthly, whatever, to your project team. To use Newforma Konekt effectively, however, you need to have enough licenses that you can give them out to all of your project team members, including the members of other design firms you're working with. It doesn't matter if the plumbing engineer you're working with already has a license for the software. If you want them to access your project hub that you are hosting on your company's account, you're going to need to provide a license to that engineer. For smaller projects, this might mean one license per design discipline. But on larger projects, you could end up needing to give out 25 or more licenses to all of your consultants. That brings us to Autodesk Navisworks Coordination Issues add-in, which is a free plugin and works with the Autodesk Construction Cloud platform. While it works best when projects are cloud hosted on BIM 360 or ACC, it can be used on its own. It does require setting up a project hub on ACC or BIM 360 because you need to associate the issues you create with a particular project. But setting up ACC projects only require one person in your company, maybe the account admin, to have a license of the BIM Collaborate Pro. Just like Newforma Konekt, there's a clash grouping tool here that allow you to group clashes by level, object type, unique object, or nearest grid intersection, as well as a whole host of other categories, many of which can be honestly completely useless, which makes navigating through the long list of options a bit daunting and possibly a bit futile. But by using the level-grid option, you can significantly cut down on individual clashes you need to review. When you have a clash you want to make sure your project team is looking at, you can right-click on it and select Create Issues from the Actions option. This will bring up a dialog where you can provide a description, assign the clash to someone to resolve, and categorize the type of issue you're logging. This pushes the issue up to the Autodesk Construction Cloud, and other project team members can review the issue in the project. For each issue created this way, a pushpin is graphically added to your model. You can then begin to see clusters of areas that need more attention. These pushpins can be turned on or off and are only visible if the Manage Issues tool has been activated in Navisworks. I'll also note here, you can manually create an issue this way by clicking the Create Issue button. You'll be prompted to place the location of the pushpin in the Navisworks model, and then you can fill in any of the information you want. Now, if you install the Issues add-in for Revit, you can then see the list of these issues from within Revit, and even see the pushpins. That said, from my experience, navigating to the clashes and isolating the elements included in a particular issue currently at this time does not function as well as one would hope. It typically just takes you to a zoomed in axonometric view of the clash, but the rest of the model is still turned on, so you can't actually see it. Anyway, from the ACC Project Hub, you can create PDF reports of all the active and in progress issues in your project, which can be distributed to your project team on a regular basis. So let's shift our attention to the last add-in, Sherlock, which aims to give you all the tools you need inside of Navisworks, so you don't really need to push any information to any other programs or platforms. Sherlock has three main features: Distill, which is what it calls its clash grouping tool; Heat Map, which analyzes all of your clashes to find the most problematic areas of your building; and Orient, which helps you quickly show people where you are in the building without needing to use the zoom or orbit tools. Unlike any of the other tools we've looked at, Sherlock's Distill feature allows you to adjust your clash group setting with a slider to be either more focused or more global. This is going to impact how many clashes get pulled together into a single group. The more focused you adjust the slider, the smaller the clash groups will be. Furthermore, within the Sherlock settings, you can adjust how groups are named so that they will be easier to sort and organize during coordination meetings. In Navisworks, you can only really look at one clash test at a time, but with the heat map tool, you can analyze any number of clash tests all at once and find the most clash-filled areas of your project. These numeric objects actually get added to the Navisworks model and are viewable as you navigate through the model. And if you publish the heat map, you can add the hotspot names as prefixes to your various clash groups, making them even easier to sort and review in coordination meetings. Additionally, you can generate new hotspot clash tests that gather the clashes from the other tests and group them together in the clash detective. This makes it even easier to track coordination progress in these problem areas. It can be hard to follow along when someone else is driving a 3D model. And while it may only take a minute or so to show someone where you are in the model at any given time, throughout an entire coordination meeting, those minutes can really add up. With Sherlock, you can select any element in your current view, right-click, and select the Orient Show and Plan option. You'll instantly be taken to an overhead plan view of your model where a big red arrow is placed to show where you were. You can quickly save this viewpoint by clicking on the camera icon in the lower left, and then just as quickly return to your previous view by clicking the Shift and Escape key. Also, Sherlock has a tool that lets you create areas or zones within your Navisworks model. For each area you draw, you can control the levels on which the area exists. These zones can be simple rectangles or whatever jigsaw puzzle piece shape you choose. Once you name your different areas, you can use the area designations in the Distill Clash Group auto-naming. As far as licensing goes, with Sherlock, you can get an individual user license at a monthly or annual rate, or one or more annual floating licenses that can be shared across all members of your firm. So this brings us to the ACC Model Coordination module. We've seen what Navisworks can do with and without plugins. But if you're working on a cloud-hosted model in BIM 360 or the ACC platform, this is an option you should seriously consider. As a web application, the Model Coordination module requires no clash detection software to be installed on your machine. Additionally, there's no need to manually export files out of Revit and manually import them into the clash detection software, because this can all be set up to occur automatically through the BIM 360 ACC platform. It does, however, take a little more initial project setup inside of Revit to get things started. First, you're going to set up a series of scope boxes throughout your building, at least one scope box per building per floor. Then you'll set up a series of view templates that isolate only the building elements from a particular discipline: mechanical, electrical, plumbing, and so on. For architecture, you should turn off things like furniture and casework, basically anything that gets put into the building after the walls and ceilings are all closed off. Then you're going to create a series of 3D coordination views, one per discipline per scope box. Depending on your project size, you could end up with a ton of views here. But this is the hardest part of project setup. We don't have it up and running yet, but we're currently looking into automating this process in-house using a custom Python script that will be run through the PyRevit plugin in Revit. All right, so next, open up your project's publish settings and create a drawing set with all of the coordination views you made. By checking the box next to the drawing set's name up top, these views will now be included every time you publish your Revit model. If you've set up weekly automatic publishing through the Design Collaboration module in the ACC, these published views will be updated automatically every week as well. And it's these views that will be powering the automated clash detection feature in the model coordination module. Now, in the models section of the model coordination module, you should see all the views you've published listed here as models. Check off all the different discipline views for a given level and click the Open in Viewer button. This will bring up a view of that level with all of the different disciplines present. Click on the Save View option and repeat this process for all the levels of your building. These views are then visible in the Views section of the Model Coordination module and can be used to organize and filter your automatic clashes. Because the default clashes view will have a very large matrix of all the different model-to-model comparisons that it's automatically running clash tests for. By selecting a view and filtering to a particular level of the building, you get a much more manageable matrix of clashes to investigate. Here, I can see there are a lot of clashes between architecture and mechanical. After clicking on the clash test from the matrix, I can change my grouping style to organize the clashes by architecture model's element type name, and quickly see that the vast majority of clashes here are with my project's most common interior partition type. After toggling the rest of the model off in the View Settings option, I can then quickly see that all of the clashes found are actually just acceptable pass-throughs of ducts and the placement of wall-hosted equipment. While selecting this clash group, I can then click the Not an Issue button and indicate that these are all valid penetrations. And then when I click OK, these clashes will be removed from the clash matrix. If you find something in your review that you want to make sure other design team members take a look at, you can select the objects involved and create an issue just like we did in the Navisworks Coordination Issues add-in. You'll be prompted to place the pushpin location, and then it will create an issue that combines the various clashes and clash groups. Just like with the Navisworks Issues add-in, we can navigate to our saved model coordination views, activate issues, and easily see where throughout the building the coordination issues are located. These issues can be viewed in Revit through the Issues add-in, and reports can be generated just like we discussed with the Navisworks add-in. All right, so I've just thrown like 2 hours of content at everybody in just over 30 minutes. You probably have questions, and I'm going to turn it back over to Jason, but feel free to email me directly with any questions you have, and I'll do my best to get back to you with answers. So beforehand, I just want to thank everyone for watching and hope that all of your clash management processes are straightforward and uneventful. So, Jason.
Awesome. Thanks for running through that. That was great stuff. And yeah, a lot of information. I jotted down, a couple questions as we're kind of walking through your presentation here. In general, it feels like using 3D models for clash detection is kind of the low-hanging fruit here. People can conceive that, they understand the benefits really quickly, but even though it seems like it's pretty straightforward, we were still finding a lot of organizations just kind of ignoring that benefit and not using it. Are you seeing most projects now utilizing the models for clash detection consistently, or is there still kind of a deficit of use?
I think it's a training issue. I don't think it just happens by simply directing people to do it. We still have a lot of projects where we'll realize people are doing the PDF overlays in Bluebeam. And it works. If you've got seasoned professionals who are used to doing it that way, they will uncover issues. But if you train your personnel on these workflows and how to do it, and they become comfortable with it, it's hard for them to go into a project without then taking the time to do these things. The last one we did with the ACC model coordination module, the fact that it's doing this sort of automatically in the background, and at any given point, you can just check in to see how things are going and dive in when you're ready, really takes the sort of effort out of the process. You know, it takes some setup at the front end, but once you've done that, it's there and it's there for the rest of your project. So it becomes a lot more fluid and dynamic.
Related to that setup, so would you compare the level of effort there similar to kind of that initial search setup in Navisworks and ACC?
So it took me a while to get comfortable with Navisworks. I think as a program, it just feels very different. It's a different environment than what I think a lot of architects at least are used to. I can't speak for the sort of engineer side of the equation. And so I feel like the training and onboarding that I've had to do to get people to use Navisworks is usually a little longer. It's still, the benefits when they see them are like, oh my God, this is amazing. And we've used both Newforma Konekt and Sherlock in-house, and we've got sort of champions of both. I've got some people who like one more than the other, and it's really just, you know, encouraging that and showing people the benefits that they're uncovering. You really, if you're not running it, you're going to have issues. That's really unavoidable. You're going to have missed something in your design if you're not taking the time to review. Yeah.
Definitely. If anybody's taken one of my classes or heard me talk about Navis, I often describe it as kind of the like the pickup truck on the farm. It's like, you know, it's not slick. You're not going to take it on a date, but man, you need that pickup truck on the farm, and it gets the job done really, really well.
Although, I even say it's like it's the manual transmission pickup truck too.
There you go. Exactly. Super granular, and it is going to get the job done. Yeah, but it is there. And honestly, I think in my head, I just never thought it would go away. But the more I see about the ACC model coordination, it's you know, they keep adding features, and that keeps adding usage cases and benefits to it. Do you think it's at a tipping point, or do you foresee a tipping point in the future where the model coordination is going to be used more than the Navisworks?
I think if either project teams start modeling in clearance requirements to their families, then you can completely rely on the model coordination module. But as of right now, between the two, Navisworks is still the only one that can handle those soft clashes. So if you're having to sort of double check your model for those clearance access issues, right now, that's the tool out there that you can do. There are some other tools that I didn't cover, Revisto being a big one, but that would be sort of its own presentation. It's on its own.
Absolutely. So my last question then, you know, you guys are multidisciplinary design firm. I'm assuming you're using these through the design phases. Are you using the same tools throughout CA? Do you have to shift and rely on contractors' tools, or how does that transition happen? And what does that look like?
Typically, we're starting this process a couple weeks into the design development process and then carrying it out through the construction document phase. By the time we're into CA and contractor or construction manager has come online, they've usually taken over that process because they're the ones pulling in actual fabrication, you know, shop drawings from their people, and they're doing the same thing, but with these other files. So at that point, it stops being, you know, about just the design and about the construction, staging, and phasing of installation. And that's something that as designers, we're not really investigating ourselves. So there's sort of a handover at that point during the CA process.
Gotcha. Awesome. Perfect. Thank you, sir. Really appreciate your time and walking us through this today.
Well, thank you very much for having me.
If any of you out there want to reach out to us, you can hit us up at any of the methods here on either email or through social media. And we want to thank you for watching today. We hope you picked up some good information on kind of a fundamental functionality and usage of 3D models that you're probably already constructing. As Noah mentioned, he's part of the BIMXT board. BIMXT is a collection of meetings, online resources that we have. Again, trying to enable, trying to educate, trying to share knowledge across our entire industry. We've got 7 city-based groups meeting throughout the year. We've got our online BIMXT Online, which is Zoom meetings quarterly, and then we have our BIMXT network on LinkedIn, where you can see this recording and all of our other AU Passes recordings that we've done throughout the last couple of years. So with that, Noah, thanks again, and thanks everyone for watching.
Thanks, everyone.